So with these 6 angles, these aren't angles that we're familiar with, but they all reduce so that they are angles we're familiar with. 4 pi over 12 reduces to pi over 3. 3 pi over 12 reduces to pi over 4. 2 pi over 12 is basically pi over 6. 8 pi over 12 reduces to 2 pi over 3. 9 pi over 12 reduces to 3 pi over 4. And 10 pi over 12 reduces to 5 pi over 6. So all of these angles that have been written in pink are our special angles. They're all special angles that we tend to put on the unit circle that are all based on either, we could represent them by a triangle whose sides we know are either 30, 60, 90 triangles or in part of a 45, 45, 90 triangle. So for all of these angles that are written here, if I asked you for sine, cosine, tangent, secant, cosecant, and cosecant, you'd be able to write them out, okay? But what about if I chose a totally different angle? If I got 5 pi over 12, that doesn't reduce. But could you build 5 pi over 12 using 2 of these 6 angles above there? The answer is yes, you can. Give it a go. So choose 2 angles that together would make 5 pi over 12. And there's many combinations. Please get this written out. It's really going to help you later on. The easiest way to get 5 pi over 12 from these angles here would be maybe to add this one and this one together. 3 pi over 12 plus 2 pi over 12. So that's really, if I saw 5 pi over 12, what I could say I'm really adding is pi over 4 plus pi over 6. So that's 45 degrees plus 30 degrees. Okay, I could build the angle 5 pi over 12 out of 45 degrees plus 30 degrees, or in radians, pi over 4 plus pi over 6. I could do it some other way as well, though. I wouldn't have to just use those. Let's move all this stuff out of the way. What else could I use? To get 5 pi over 12, I could use, starting with this one. What would I have to do to end up with 5 pi over 12, starting with that? To get 5, I get 9 and subtract 4. So it could come from 3 pi over 4 minus, that's pi over 3, which is 3 pi over 4, that's over here, that's 135 degrees. I don't know better in radians now. 135 degrees minus 60 degrees. Okay, so you're getting the idea. We can get an angle we don't know, and we can split it into 2 angles that we know lots of stuff about. Okay, and there is an exercise that you could do. But the lesson is long today, so I'm not going to spend time on it. In my first class, I got them to build these other angles as well, just using those, and we showed that there was many ways to do it. But we're not going to do that because that takes too long. What we're going to be doing today is Unit 5.4-1, Sum and Difference Identities. So I'm going to want you to take a screen grab of this. You want these written out really nicely in your notes. These are identities. Remember what the word identities means. These aren't just equations. They are relationships. This equals this for every single value of A and B. For any angle A and angle B, the sine of A plus B equals the sine of A multiplied by the cosine of B plus the cosine of A multiplied by the sine of B. Okay? They're identities. How you would use them, say I wanted to find the sine of 75 degrees. I could say, oh, I don't know 75 degrees, but I know lots of stuff about 30 degrees and 45 degrees. So the sine of 75 degrees is the same as the sine of 30 plus 45. So every time I saw an A, I'd put 30. And every time I saw B, I'd put 45. So the sine of 75 degrees would be the sine of 30 times the cosine of 45 plus the cosine of 30 times the sine of 45. And I go to work that out because I do know the sine and the cosine of 30 degrees and 45 degrees. Okay, I'll give you a minute to write these out. A minute or so. You want to write them out neatly, they're really important. And leave a little space around them because I'm going to tell you a way to remember them. Let me give you a minute to write them out. So, one of the ways you can memorize them is this silly saying here. Do you see these two are the sines, these two are cosines, and these are tangents? For sines, can you see we have what I call a sandwich? We have a same sign sandwich. It's the same sign. It's sine because it sines. It's the same because whatever math operation is here is also here. And it's a sandwich because here's your bread on the outside. It's a sine sandwich. Your bread is the sines and the filling is the cosines. It's the same sine sandwich, okay? If you see that pattern, you know that you're talking about sine of either A plus B or A minus B, and you know whether it's plus or minus by looking here, yeah? So that's the same sine sandwich. You'll see that sine of A minus B again, you've got your bread here on the outside. One of the things I should have pointed out first is if you look at any of them, just read out every time you see A or B. It goes A, B, A, B, A, B. 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 A, B, A, B, A, B, etc., etc. The pattern never ever goes A, B, B. The angles always alternate. So when you've written out your work, glance quickly at it before you get on to the next step and check that your angles are alternating. You never write the same angle twice in a row. Okay, that helps. So that's how to remember the sines. You look for a same sign sandwich. That doesn't happen with cosines. With cosines, you get a list of two cosines, and then that's a minus when that was plus, so that changed, and then you get a list of sines. So it's not a sandwich at all. My silly saying for this one's not that silly, it's just cosines change sines. So you get a list of cosines, whatever was here, you change it and write the opposite there. So you write your list of cosines, you change a plus to a minus or a minus to a plus, and then you write a list of sines, and again your angles go A, B, A, B, A, B, A, B. Okay? So that's how to remember the sines, the cosines. The tangents, I haven't got anything for you. Except for, let's just think, wouldn't life be nice if the tangent of A plus B was simply the tangent of A plus the tangent of B? Well, that's not true at all. This equals all of this, not just the numerator. The numerator is just part of it, yeah? But that is how it starts. Tangent of A plus B, just write out what you wished it was in real life, because that would be so easy. And say, oh, but it isn't, it's a fraction. And then you've got 1 minus multiplying those two things together. Whatever you wrote here, you write the opposite there, okay? This, you write the same in the top, the opposite in the denominator. That one you just kind of have to remember. Okay, let's move on to actually using these things. So, we don't need to write all this out yet. Let's just talk about it. If you had a question that said, evaluate the cosine of pi by 12. Another way of wording the question would be, find the exact value of the cosine of pi over 12. And that word is exact is important. Cosine, sines, tangents, any of these trig functions are irrational numbers. They normally, from most angles, are a number that goes on and on and on forever. If you type that into a calculator, if you have a calculator that works 10 decimals, you'll get an answer to 10 decimals. If you had a calculator that could work to 100 decimal places, you'd get a list of 100 numbers after the decimal point. That's really precise, it's really accurate, but it's still not exact. Okay? If it says exact, basically I don't want a decimal approximation. Not even to 100 decimal places, that's still not exact. It's precise, but not exact. When we're being asked for the exact values of these, they're often going to have square roots in them, like the square root of 2, square root of 3, square root of 6, that sort of stuff. Okay? So how to do these problems? If I've been asked for the cosine of pi by 6 or the cosine of pi by 4, you know how to do that because we can draw a triangle that represents them. But we can't draw a triangle to represent this angle. However, we just showed in the warm-up that we could represent pi by 12, an angle we don't know, with two of the angles we do know. Now, there's several choices. To get to pi by 12, you could start off with 9 pi by 12 and take away 8 pi by 12. That's using like 3 pi, that reduces to 3 pi by 4 minus 2 pi by 3. Those are angles we know. They're in quadrant 2. An angle in quadrant 2 is less useful than an angle in quadrant 1. It's still good, we could use it, but be careful if you're not in quadrant 1 because you're going to have something that's going to be negative. Either the sine, cosine, tangent, 2 of them will be negative for any angle if you're not in quadrant 1. So if possible, let's stick with angles in quadrant 1. It won't always be possible, but you're less likely to make an error if we use angles in quadrant 1. So I could use 4 pi by 12 minus 3 pi by 12. That gives me 1 pi by 12. Or I could use 3 pi by 12 minus 2 pi by 12. This one here would be using pi by 3 minus pi by 4. That's how they reduce. This would be using pi by 4 minus pi by 6. So I could use any of those combinations. If I've worked out several combinations, I'm going to think, I'm going to reject that one because not everything's in quadrant 1. Sometimes you have to work with angles that aren't in quadrant 1. I could use either of these two, and they're both going to give me the same answer, but the work in the middle is going to look different. Let's use this combination. Okay? So, what I'm going to do is the first thing I'm going to do when given this question up here is first of all, I'm just going to look at the angle and say pi by 12 could be written as 4 pi by 12 minus 3 pi by 12, which in terms of angles I know is pi by 3 minus pi by 4. Okay? So now, when I see pi by 12, in its place I can write this. Go back to the question. The cosine of pi by 12 could be written as the cosine of, now I do need parentheses here, because I'm not going to just be writing one thing. Instead of pi by 12, I'm going to write pi by 3 minus pi by 4. I better stop this and yell in that hallway. Okay, so let's look at that. That's one of these identities. It's the identity of cosine. That's like your A, cosine of A minus B. Our A is pi by 3 and our B is pi by 4. So the next thing to do is write out your identity. Get that formula and write it out. That gives you a point on the test. Just identifying the right formula to use. Let me make that a bit bigger. Oh, come on. My board's not calibrated well. I use the mouse. Okay, so write that out now. And then let's replace, every time I see A, I'm going to write pi by 3 instead. So for this A, I'm going to write pi by 3 there, and for this A. And everywhere I see a B, I'm going to write pi by 4 instead. I'm going to write it color-coded, you don't have to. So basically it's the cosine of something multiplied by the cosine of something plus the sine of something multiplied by the sine of something. Okay. A was pi by 3 and B was, I'm going to do my B in blue. Right, so now we need to replace those with what they're equal to. What is the cosine of pi by 3? What is the cosine of pi by 4? What is the sine of pi by 3? What is the sine of pi by 4? Remember that a cosine is simply an x divided by an r, and a sine is a y divided by an r. So how we learn this at this school is we draw our special triangles. Draw this triangle for pi by 3, 60 degrees, label the sides, and tell me what we're going to need the cosine of that, and we're going to need the sine of it. Then for the angle pi by 4, that's a 45, 45, 90. We're also going to need the cosine of that. And we're going to need the sine of that. So this one's easy. 1 root 2. Cosine of pi by 4 is x divided by r. That's 1 over root 2. That turns into root 2 over 2. And the sine is also the same thing. 1 over root 2, it's y divided by r. On a 30, 60, 90, remember, this is the big angle. Your y is going to be the long leg, root 3. There's the 30, your x will be 1 on this one, and your r is 2. So the cosine of pi by 3 is your x divided by your r, it's 1/2. And the sine of pi by 3 is your y, root 3 divided by 2. So let's go back to our problem. When I see the cosine of pi by 3, I'm seeing this, it's equal to and can be replaced with 1/2. Let's remove all this horrible junk off my work. But that's what I'm doing now. And when I see the cosine of pi by 4, look to your triangle over here, the cosine of pi by 4 is root 2 over 2. Then I've got the sine of pi by 3, which I said was root 3 over 2. And the sine of pi by 4 is root 2 over 2. Okay? So that's just substituting something with what it's equal to. Now look at what we've got here. We've basically got two terms. Remember, terms are things separated by addition or subtraction. Multiplication doesn't separate terms. This is one term here plus another term here. Okay? So I've got two ugly fractions equal to each other. So work that out for me. Work out what they are. So when you're multiplying fractions, what we've got here is we've got this fraction being multiplied by that fraction. Go across the top. 1 times the square root of 2 is the square root of 2. Multiplying the fractions, go multiply across the top, multiply across the bottom. The denominator is not going to be 2, it's going to be 2 times 2, which is 4. When you're doing fractions, you add the tops and they've got to have a common denominator, and you don't put the denominators together. So in this second term, we're multiplying those two together. Again, the denominator is going to be 4. Now think about multiplying across the top there. When you're multiplying the irrational numbers, when you're multiplying them, you can bring them together under the same house. If I was adding those, you can't. That would not be the square root of 3 plus 2, would not be the square root of 5. You can't add them together under the same square root symbol, but you can multiply them together. So when I'm multiplying across the top there, square root of 3 times the square root of 2 is the square root of 6. Let's clean up that answer a bit. It's basically they've got a common denominator. Let's look at the numerator. It's just going to be the square root of 2 plus the square root of 6. That is not, do not say that's the square root of 8. You can't add them together. Two irrational numbers like that, you can't add them together like that, but you can multiply them. That's our answer. Now, at the very beginning, when we chose our angles, pi by 3 and pi by 4, if we'd chosen a different combination of angles that still gave us pi by 12, we might not have got the answer to look quite like that. We might have got this answer. But can you see that's the same thing? When you're adding things, the order doesn't matter. You can switch it. If we were if that had been a subtraction, we would have ended up with negative root 6 plus root 2. There wouldn't be a negative there, yeah? That would be if it was subtraction, but it's an addition one. This is the same thing as that. Okay, we're not going to do that one because the lesson is too long. We're going to do a tangent because tangents take a lot of work. Now this one's going to take up quite a lot of space in your work. I suggest you start a new page and get this one written out really neatly because we're going to do some algebra manipulation at the end that you probably want to have written out nicely. Okay, so we're going to do this one now. We're going to evaluate or find the exact value of the tangent of 5 pi by 12. The first thing you do is you sort of cover up the trig function and just look at the angle. And we're going to choose 2 angles that could give us 5 pi by 12. There's all sorts of combinations, and they give us the same answer at the end, but the work in the middle would look very different. Let's just use for this, let's use 2 pi by 12 to get to 5, and we use 2 pi by 12 plus 3 pi by 12. Those are the standard, the special angles we know. 2 pi by 12 is pi by 6. 3 pi by 12 is pi by 4. Oops. So, when I'm asked the question, find the tangent of 5 pi by 12, I could say, okay, I'm going to split that 5 pi by 12 into pi by 6 plus pi by 4. That does add up to give me 5 pi by 12. So now write out your formula. We're using one of these. It's obviously a tangent, and it's a tangent of, this is like A plus B. We're going to find our tangent of A plus B formula. So I can just slide it across, you have to write it out. So when we see the A, look at it. A is in the place of pi by 6, B is in the place of pi by 4. So when I work this out, I'm going to want the tangent of something plus the tangent of a different angle, then one opposite of plus is minus, tangent of one angle multiplied. Make your multiplication really obvious. Make it really obvious if you're multiplying or dividing. And our angles for sticking in there are pi by 6 and pi by 4. So now we've got a formula written out with our angles in them. Now we want to find the value of each of those trig functions. So we want to do some little work on the side so we can work out what is the tangent of pi by 6. We want something for that. Draw a pi by 6 triangle. That's 30 degrees. 1, root 3, 2. The tangent of an angle is the y divided by the x. So it's, it's 1 over root 3, which we write as root 3 over 3. Then I'm also going to need to know, this is, if you know these, you can just write them straight down. If you've memorized your unit circle with all these values, you might even know that these without having to do any work. Tangent of pi by 4, we draw a 45, 45, 90 triangle. Tangent of pi by 4 is y divided by x. It's 1 divided by 1, so it's 1. Okay, let's go put those values into this work here. When I see the tangent of pi by 6 in the place of the tangent of pi by 6, I'm writing that. Then I've got plus, when I see the tangent of pi by 4, I'm writing something that it's equal to. I'm writing just 1. When I see tangent of pi by 6, I'm writing root 3 over 3, and I've got multiplied by 1. Now our job is to clean this up. First of all, this multiplying by 1 is not doing anything much at all, yeah? So we have got at this point, we're looking at the square root of 3 over 3 plus 1 over 1 minus the square root of 3 over 3. We've been doing that the last few days with words in it. So now we've got numbers in it, it should be easier. There are various ways to do it. On my keys online, you'll see I've done it by this technique. But when I teach it that way, I find that students who are a little bit weaker at fractions get lost. So I'm not going to actually model it that way now. I'm going to do it the technique when we do division of fractions using keep, change, flip. So I want all of this to be one fraction that I'm going to keep. It can only be one fraction. And I want this to be another fraction, just one single fraction. So to do that, I'm going to put them over a common denominator. I'm going to use the denominator 3. So this 1 here, I'm going to rewrite as 3 over 3. And this 1 here, I'm going to write as 3 over 3. So let's write out that fraction one more time, but with just one fraction in the numerator and one fraction in the denominator. In the numerator, they've got a common denominator of 3. And my numerators are root 3 plus 3. I don't need quite such a monstrous fraction there, do I? And then the denominator, I've got similar. The common denominator is 3, but instead of this 1, I've rewritten as 3 over 3. So the numerator here is 3 minus root 3. Now I can use that multiplying by reciprocal, which is easiest to do if you think of it as keep, change, flip. So what we're going to do is keep the numerator, change division, this division here, to multiplication, and then we flip, we write the reciprocal of the denominator. So flip that upside down. Okay, now let's look at what we can do. When we're multiplying fractions, this is a factor of both the numerator and the denominator. We can cancel that out. Oopsie. Sorry, my board's going a bit weird today. So at this point, we've got the square root of 3 plus 3 on the top divided by 3 times the square root of 3 on the bottom. Now, we can't leave our answer there because we've got an irrational number in the denominator. Don't copy me now just for a minute, because I'm going to show you something that won't work. Normally, when you have square root of 3 in the denominator, don't do this, I'm going to erase it. Normally, when you've got the square root of 3 in the denominator, you would multiply it by the square root of 3, because that would give you the square root of 3 squared, which is 3. And it gets rid of that irrational number. But that's not what we've got. We would normally do this, multiply by that carefully chosen form of 1. But look, you'd have to multiply it by that as well. So you're not going to get rid of the irrational number if you do it the way that you're used to. That's not going to work. So let's do something else. What we know will give us squared stuff on the denominator would be if we introduce the difference of squares. The difference of squares gives us a squared minus b squared. It'll square everything. It's always going to get rid of an irrational number caused by a square root. So to introduce the difference of squares, I'm going to multiply this denominator by its conjugate. Where there's a minus here, I'm going to write plus. And if I'm multiplying the denominator by that, I also have to multiply the numerator by that. So I've introduced difference of squares because that will get rid of any irrational numbers in the denominator. So your denominator now becomes 3 squared, which is 9. Difference minus, it's that first thing, that's your 3 squared minus your square root of 3 squared. And what is the square root of 3 squared? Just 3. That's in the denominator. Now there's no easy way to do the numerator. We're going to have to multiply this out by FOIL. So our first term is going to come from square root of 3 times 3. Then we're going to have our outer. So we've done the FOIL. We're doing FOIL. The outer comes from square root of 3 times the square root of 3. So that square root of 3 times the square root of 3 is 3. Then we have to do the inner. That's 3 times 3, which gives us 9. That was the inner. And then we do the last. 3 times the square root of 3. Okay, now let's clean that up a bit more. The denominator, it's easy, it's 6. An easy thing to do here would be to add up that 3 and that 9. That gives me 12. My first and my last are both 3 times the square root of 3. 3 times the square root of 3 plus another 3 times the square root of 3 gives me 6 times the square root of 3. Now, you can split a fraction into 2 fractions by splitting the numerator. I can split this here. So I can split that into 12 over 6 plus 6 times the square root of 3 over 6. And now it cleans up beautifully. 12 divided by 6 is 2. And on this one, the 6's cancel, we're left with the square root of 3. Okay? So these tangent ones, that's often going to happen in a tangent. That you're going to end up with an irrational number in the denominator, and you have to clean it up by bringing in the difference of squares to rationalize the denominator. We do that by multiplying in the conjugate. Tangent ones can get long. We have a couple more questions to do. The goal of today, we were actually going to have a closing task, but the lesson's too long. I'm going to give you the closing task another day. We have one more question I really, really want to go over with you. A couple of questions, actually. They're quick, these ones. So let's have a look at this one. Write out this question and see what it says above in blue. Write as the sine or cosine of a single angle. So our answer could be sine of something or cosine of something. Look at what you've got there. Can you see this is a sandwich? So it's the same sine sandwich. That tells me it's got something to do with one of these identities, and it's the same sine sandwich. I'm looking for the one with a minus there. So it's this one. Write out this identity, and look what we've been given. This time, we've been given this side, and we can say, aha, it's equal to this side. So even though this question looks so much more difficult when you see it than the other type of question, it's actually easier. Erase that stuff. So we have been given this we've been given this side here, and we can say it is equal to the sine of same sign, that's a minus there. Look at what we've been given. Our A equals 75 degrees, same here, look. And our B equals 35 degrees. So what we've been given here is the sine of 75 degrees. Where I see A, I replace it with 75. Where I see B, I replace it with 35. So this could be written as simply the sine of, do that subtraction. What is 75? Take away 35? 40. Have I finished, or do I have to work that out? Read the question again. It says, write as the sine or cosine of a single angle. That's the sine, so it's the sine or cosine. That is one angle. I'm done. I'm finished. Try the next question. Looks really difficult. It looks long and ugly, but it's very sweet. It's very easy. Look what you've been given here. You've been given a sine sandwich. So it's the same sine sandwich again. We want this. I need to write a different question for this one. It's the one with the minus in. So it's the one we've just done. It's exactly the same one we've just done. It's based on exactly this formula again. It won't work for me. It's this again, but this time we've been given our A is pi over 18. This is sine of A, cos of B. So our B is 3 pi over 18. This is cos of A, it's reconfirming our A is pi over 18. This is just reconfirming our B is 3 pi over 18. So we've been given this side of the formula. We can, or identity, we can replace it with this side. So we've been given this side this time, and they're saying that is equal to the sine of A minus B, where A equals pi over 18, B equals 3 pi over 18. So we just have to say sine of A, replace it with pi over 18, B, replace it with 3 pi over 18, and now that's two angles. I haven't finished yet. I've got to do that math and simplify it. So what's 1 pi take away 3 pi's? Minus 2 pi. Reduce that, that can be simplified. 2 goes into 18 9 times. So that is the sine of one angle. We've answered the question in the format they wanted us to. Okay. So you have some homework tonight. Please, it's due tomorrow. I don't give you a late grade if you don't hand it in tomorrow.